And here we go. Hey guys, welcome to Money Farming YouTube channel. And in this video, we're gonna be talking about continuing our discussion on configuration file. Okay, so let's go ahead and continue. Yeah. Now, where we were left off around here. Okay, so we talked about what it all means. This ampersand and at and all this you know convention of using column naming. Okay, column naming convention basically for defining target features and like different um, different sort of column in your data frame. Okay, so for training we have ampersand, and for labels, training labels, we have like at and sign. Okay, so hang on, let me see if it looks good here or not. Yeah, I don't like that there, so let me put it there. Yep, chat, I'm gonna put it here. Yep. Okay, so let's continue. So setting the startup candle count. Okay, so if I go here and search startup candle count, here we have put it to 40. Okay, so this is the maximum period fed to TLA. Okay, so this is basically like a time period of the startup candle count. So basically if you have SMA, simple moving average, around 50, then you should use 60 startup candle count, that you need at least 60 candle to compute that feature. Okay, so I think that's what they talk about here. So the startup candle count in the FreqAI strategy needs to be set up in the same way as the standard FreqTrade strategy. So this value is used by FreqTrade to ensure that a sufficient amount of data is provided when calling the data provider. Yeah, to avoid any dot a number value or at the beginning of the first training, you can easily set this value by identifying the longest period in candle units, right? So which is passed to the indicator creation functions, that is TLE functions. In the presented example, startup candle count is 20, right? So since this is the maximum value in indicators period candles, okay, so that's how we named it as 20. Okay, so here's a note. So there are instances where the TLE functions actually require more data than just the past period, or else the feature data set gets populated with NANs, right? So this is just like they're talking about that if we need more startup candle or not. So anecdotally, multiplying the startup candle count by 2 always leads to a fully NAN free training data set. Hence, it is typically safest to multiply the expected startup candle by 2. Look out for this long message to confirm that the data is clean. So basically, we see this and like drop to 0 training point 0 to NAN's populated data set. So we can look into it about our log file. Okay, so this is training. Actually, we can look into it. So here, actually like it dropped 20 to 20 training points from due to it was NAN. So 20 is not that much, but if it instead of 20 it would be 200, then we might have to go back and like look into it, what the heck is going on there, right? So yeah, right. Even though here we can do it multiply by 2. Okay, it's not a problem. Yep, so let's get to the good stuff. So here it says like creating a dynamic target threshold. So deciding when to enter or exit a trade can be done in a dynamic way to reflect current market conditions. So FreqAI allows you to return additional information from the training of a model. So it's like we can look into it, what additional information we need, which is this, Um, so for example, and star standard deviation mean return values describe the statistical distribution of the target level during the most recent training. So comparing a given prediction to these values allows you to know the reality of the prediction. Okay, so in this example that we were seeing this one, the target ROI and cell ROI are defined to be this 1.25 G scores away from the mean, which causes predictions that are closer to the mean to be filtered out. Okay, so basically what they're talking about this. Where is it? Does it calculate automatically? Um, think we can set it up here. I think so. Yeah, so this now we can like actually set it up here. Okay. So if I do it like this, bring it here, it will take care of it, the threshold. So okay. Yeah, I need data frame. Okay, sorry, it's different one. Hang on. Yeah, we were doing the modification here. Yeah, so so to consider the population of historical predictions for creating the dynamic target instead of information from the training, as discussed above, you would set fit live prediction candles in the config to the number of historical prediction candles you wish to use to generate statistics. Basically, what they are showing is like so here we have ROI, you know, here actually we have like minimal ROI, so target ROI, sell ROI, you know, we can basically get it dynamically. Okay, what how we can basically get that prediction is from, as we get the prediction, suppose the prediction, our prediction is like 20 candles away. So what they are saying now is like actually it's better to explain it here. So suppose like your candle is like this and you want to predict the candle here. So suppose the prediction, you know, tells you that like price is going to go up, so you have this difference. Okay, so you're going to get the price of prediction with the normalized value. All right, you see this one, you see this one, this, that's your prediction, normalized close prediction. Okay, so from that perspective you have your mean and standard deviation. So you can basically get the ROI, return on investment, like how much that is predicting, so that once the market goes there, you basically take out your trade and like you know, get out of the trade there, you know. So yeah, I hope that makes sense. Yeah, so yep. Now this is what they are saying is like to fit it for the last 300 candles. So um Bhimsen Lama, can I have your script, sir? Yeah, for this machine learning model that we are doing here, you can actually find it on you know, on the official website. But as soon as we are done with this strategy, with this machine learning model, I'm gonna be publishing it on my GitHub account. So I'm gonna start new GitHub. So you know, it's like money farming GitHub account, and then where there I'm gonna upload it, all this stuff. Okay, so don't worry, I'm gonna soon like upload the scripts as well. So yep. All right, let's move on. So here they say to consider the population of historical predictions for creating the dynamic target instead of information from the training, as discussed above, you would set fit live predictions candles in the config to the number of historical prediction candles you wish to use to generate target statistics. Yeah. That's actually not my, that's, I think if you have found that GitHub, no, that's my personal GitHub. So, um, so this is my personal GitHub. Okay. I'm gonna open like new GitHub account. Yeah. Yeah. Yeah, I'm gonna be like uploading it for like reproduction as well, so that you guys can just run it and reproduce it, you know. Yeah. So if this value is set, FreqAI will initially use the predictions from the training data and subsequently begin introducing real prediction data as it is generated. So FreqAI will save this historical data to be reloaded if you stop and restart a model with the same identifier. So this is also very important. Okay, so fit live prediction candle. So for the last 300 candle, it's gonna fit the prediction on. So we can just look into it. Where is it? Fit live prediction. So hang on, I'm just gonna like put it there. Fit live prediction candles. So are you new in this channel, Bhimesh Lama? Bhimsen, sorry, Bhimsen Lama. You're from India, I think, right? Yeah, man, it's gonna be a big thing in India, trading and all this stuff. It's really gonna be a big thing. Actually, I'm thinking of starting this new podcast where I talk about the mindset of like trading, because I talk to a lot of people and like the only thing that I hear is like, crypto is dangerous, this is dangerous, that is dangerous. Like, do you know about crypto? Or are you just like, did you just learn about dangerous things? Like, you know, like what the fuck is going on? You should know about this stuff, then you should like, you know, talk about it. Otherwise, like if you just like danger, then like, yeah, you should be like, you know, Will Wilson in uh, in uh, what was the series called? uh Space, like, you know. Yeah, danger Will Williamson, I don't know. Yeah, guys, just like crypto is very easy. Okay, and nowadays all this technology, we are getting it for free. We should better, you know, make good use of it, you know, instead of saying just danger. No. All right, that's why this channel is for, you know, to teach you guys about money farming. You know, we used to farm about like 50 years ago. Every each one of us, our parents, knew how to like farm, you know, to like put food in our belly. But nowadays we have forgotten that, you know, we work for someone else. We wait for the money to come, then we can eat. But like if just imagine if we can like learn about farming, man. Like if we knew about farming, we don't have to worry about food. We already have shelter, we got the food. Live your fucking life then, like, you know. But nowadays the arena has changed, you know. The arena has made up of like money. It's like we need money for every single fucking thing. That's why, like, you know, that's why I started this channel called like money farming. I'm gonna teach you guys how to farm money. There's already one term called like yield farming, you know, yield farming, if you guys know about it. But like they are no, it's like, so if you have like, suppose if you have $100,000, okay, so now you put on the like there's like neofi or something. So if you put $100,000 now, take 50% of it, which is $50,000, you can spend it. Okay, now yield farming, it means like you let it on that platform for 1 year, and whatever return you get, no, it's from that $100,000. And you can spend that $50,000. So just imagine, like it's really a good deal, you know. So yeah, that requires some money. So that's why, like, I'm gonna teach you guys everything in this channel. Okay, so yeah. Okay, so if this value is set, FreqAI will initially use the prediction for the training data and subsequently begin introducing real prediction data as it is generated. So FreqAI will save this historical data to be reloaded if you stop and restart a model with the same identifier. Yep. So this is what we were talking about, the importance of this identifier. Okay. So yeah, so for this, yep, we're gonna change the identifier. Okay, now let's move on, and I think now we are moving on to the good part. So using different prediction models, I think should I keep it like here, you know, I don't know. Yeah, this is fine. Yeah, or perhaps around here. What do you guys think? Is this is this good position to keep the, you know, video on? I'm just like exploring what works. I don't know. So let's move on using different prediction models. So FreqAI has multiple example prediction model libraries that are ready to be used as is via the flag FreqAI model. Okay. Now these libraries include CatBoost, which is categorical boosting, gradient boosting library, LargeGBM, and XGBoost, extreme gradient boosting library. So regression, classification, and multi-target models, and can be found in FreqAI prediction models. Okay. So what they are saying now is like, so here as we go on this one, so we can actually go to the library, FreqTrade GitHub. Then so FreqAI, this is what they're talking about. CatBoost, LightGBM, PyTorch, reinforcement learning, XGBoost, you know. So yeah. So regression and classification models differ in what targets they predict. Okay. A regression model will predict a target of continuous values, right? And for example, what price Bitcoin will be at tomorrow. That's your regression problem. Okay. You're regressing and like asking model to give me or tell me what's the price of Bitcoin gonna be, or just the percentage change within that price. Okay. Which is continuous, by the way. Okay. Whilst a classifier will predict a target of discrete values. Okay. For example, if the price of Bitcoin will go up tomorrow or not, that's just categorical value or discrete. Okay. Up or not, that's it. Okay. This means that you have to specify your targets differently depending on which model type you are using. Okay. So all of the aforementioned model libraries implement gradient boosted decision tree algorithms, which is very important on tabular data. So they all work on the principle of ensemble learning, okay, where predictions from multiple simple learners are combined to get a final prediction that is more stable and generalized. The simple learners in this case are decision trees, okay. That's what we are doing here. So they're like different classes of deep learning models or machine learning models. So first we started with just like pure regression, you know, which is like your OLS, like, you know, um, linear regression is so it's just like y equals to mx plus c. You feed the line on the data. Okay. Now moving on to your multiple MLP, you know, it's like multi-layer perceptron. You can add. This is just like neural network, you know, but decision trees are like bit different as compared to. So what we do in this decision tree is like we have like different. We have all the column is like they do some like operation as a like node of tree, and they're like, you know, they produce some results, and then that result gets like um you know, it like gets back, like it's kind of like related to back propagation, but it also has a learning rate and all, but the only thing that they optimize is the result. Okay. And it has like different layers of n estimators, you know, basically trees that you can use to predict or fit the model. So that's what we're gonna doing here. Okay, so gradient boosting refers to the method of learning where each simple learner is built in sequence. The subsequent learner is used to improve on the error from the previous learner. If you want to learn more about the different model libraries, you can find the information in the respective documents. So CatBoost there, LightGBN is from Microsoft, XGBoost is just XGBoost. So CatBoost is machine learning algorithm that uses gradient boosting on decision trees. It is available as an open source library, so you can train it on GPU, CPU, and everything. Okay. You have LightGBM from Microsoft. Um, so you can look into the documentation, and XGBoost. This is the granddaddy of all gradient boosted library. Okay. So yeah. So let's continue. So there are also numerous online articles describing and comparing the algorithms. Some relatively lightweight examples would be CatBoost versus LGBM. So it is like comparison showing like which algorithm is best for that. So you can look into it. And XGBoost, this also, which boosting algorithm should I use? Keep in mind that the performance of each model is highly dependent on the application, and so any reported metrics might not be true for your particular use of the model. Apart from the models already available in FreqAI, it is also possible to customize and create your own prediction models using the iFreqAI model class. Okay, so you are encouraged to inherit, fit, train, and predict to customize various aspects of the training procedures. You can place custom FreqAI models in user data. FreqAI models and Freq trade will pick them up from them. They are based on the provided FreqAI model name, which has to correspond to the class name of your custom model. Make sure to use unique names to avoid overriding built-in models. So what they are saying basically is like, when we go here, so if I see this XGBoost regressor, so I go there. So so this is actually a base model that you have to inherit, and then you have to just override the fit model, fit, train, and predict. So what it is here is like, if I take the catboost, okay, let's just take the classifier. So here there's just like fit, but um so prediction models, FreqAI, okay, base models, prediction models, okay. So that's what we have to do. Okay, here, so fit, train, and predict to customize various aspects of training procedure. So we only needed fit on that like simple inherited class, because we already, this code is same for train and predict, so we just have to fit. And train is basically for deep learning model, you know so yeah. All right, so setting model targets for regressor, we use this. So this is what they mean. So let's actually set the target. So this is to set the target, we need to do this. Okay, I think it's messing things up, so I'm gonna put it around here, I suppose. And just like what we are reading now, it's like it's gonna be there. Okay, so let's see. Yeah, so here, if you want to do regression, so if you are using a regressor, you need to specify a target that has continuous values. Okay, so FreqAI includes a variety of regressors, okay, such as the CatBoost regressor via the flag FreqAI model CatBoost regressor. An example of how you could set a regression target for predicting the price 100 candles into the future would be this. Okay, so close shift -100. Okay, so this is what we did here. So what we did here, so df and percent as close, what we did is like df close shift -100. So what it's doing, like, I want to predict 100 candles into the future of future the price of coin. Okay, so that's what we're gonna do. That's what it's doing. But here what we did know is like the label period candle. Okay, so this is actually like we are getting it from our config file. So if I go to config file and search for this, see this is the label period candle. So here you can set 100 or 20. Okay, 200 or 20. And how you get it, it's like you get it from this. So if I do it here, no, it's like this. So I just like do it minus cell.freqai info. So this is the config file that we get um, from FreqAI, and this is how we set it. Okay, so this is the same as what we had on here. All right, so if you want to predict multiple targets, you need to define multiple labels using the same syntax as shown above. So suppose we predicted close. Okay, now suppose if I want to predict the high price. Okay, so I can say high here, high. That's it, right? So this is our like multiple target now. Okay, all right, so this is how we do it. All right, so okay, so let's go ahead and continue. All right, so classifiers. If you're using a classifier, you need to specify a target that has discrete values. FreqAI includes a variety of classifiers, such as the catboost classifier via the flag, FreqAI model, catboost classifier. If you elect to use a classifier, the classes need to be set using strings. For example, if you want to predict the price 100 candles into the futures goes up or down, you would set it as this. Okay, so let's write it down because I want you guys to practice. Okay, this is how you practice. Okay, whatever they're writing, no, you should also write it. All right, so that like even you can like copy the code, but like to practice you have to write it. All right, so let's continue. So you can see here, in order to set the different classification of target. So if you want to predict, okay, my 100 candles into the future, tell me this machine learning model whether it's gonna go up or down. Okay, so in order to just compare that, we just have to check, okay, if the 100 candle in the future is it greater than our current candle or like less than. Okay, so that's how we set it. For that we use np.where, and we see if my close dot 100 candles into the future, or just like let's take 20 for this case. So if this is greater than that, then we set up, or otherwise we set down. Okay, so this is my okay, so this is and as up or down, or just like say prediction up or down. Okay, so we got that. Let's import numpy. Okay, so we got that here. Let me know guys if you guys have any question. Okay, have you done this before? Have you did like deployed classification model before in with FreqAI? I don't think, because like most of the people, they go for regression. They don't like use classification model, but classification model can be very useful. Yeah, it's this is the only thing that I'm gonna use, to be honest. I'm not gonna use regression more often. Yeah, okay, so here we only had two classes, like up or down. Now if you want to predict multiple targets, you must specify all labels in the same label column. So you could, for example, add the label same to define where the price was unchanged by setting this. Okay, so just do this, and instead of that, what we do is like we check if it's equal, then we just like do the same. Otherwise we take the column of that. Okay, so this one. All right, so we got the multiple targets. All right, now this is really cool part that we came into right now. Okay, this is what I like, deep learning, man. Like, this is the, you know the AI hype that has like gone too much. No, it's like really cool for trading as well. So ChatGPT, to be honest, like it really has something. Um, so when someone is asking, the shift minus 20 is try to train future 20 candles, right? No, it's just a prediction. It's not to train the 20 future 20 candles. It is actually like predicting with all the data we have in the past. We're trying to predict, okay, whether 20 candles in the future, are we going up or down. So you can see it like if 20 candles later, if the price of Bitcoin is going to, right now price of Bitcoin is 56,000 something. So 20 candles later on 4 hour candle, it should be around, I mean, it's going down, but so okay, that's why I like to show this one. Okay, so check this out. All right, so this is our chart. All right, live trade prediction. So market is around here on the support. So see this, market bounce from here, bounce from here, bounce from here, bounce from here. So now here, now machine learning model would see, okay, what to do now. All right, now if you see that, like this was very big down wave, up wave, down wave. So our model predicted it right. Now here we can see what's going to happen from 20 candles later on. Now I predict that the market is still going to go down. All right. Now, in order to set that in candle, no, what we do is like we basically normalize it so that we don't really predict the price, but instead we predict the percentage change of like whether it's going to go up or down. So if it's up, then it's positive percentage change. If it's down, then it's negative percentage change. But the question you're asking is it's actually like just for prediction. Give me 20 candles into prediction. Okay, that's it. So yeah, all right. um, hmm. So let's continue. um, so this is the part which I really like. um, PyTorch module. So let me know, guys, in the comment, what do you guys think about PyTorch, and like what's your experience with it, because it's really important. Okay, because I'm telling you, Exibus is not gonna cut out for building a profitable trading strategy. Okay, and so they had TensorFlow integration, but like TensorFlow has like a lot of rolling releases and like changes, no, so they just kept it with PyTorch only. So all the deep learning modules that we're gonna write later on is gonna be with PyTorch. Okay, so I just want to see your guys' reaction, like what do you guys think? Because the regression model that we have with Exibus, we can implement in the same with deep learning, but like deep learning is way more powerful than just gradient boosting library. Okay, so yeah, let's continue. I think I can like make it very smaller and put it there. Yeah, okay, so let's see. All right. Hmm, okay, so okay, line 152 df close should be dfs close. Yeah, it doesn't matter actually. um it can be like 152, right? So it's just like it should be ampersand. Okay, this this is actually just the name. Okay, when we want to use it in prediction now, so for instance, here when you go, see, check this out. Okay, so this is the same as here. Now when you do predict, no, you use it this like this. So you can name it either way you want. Okay, yeah, it doesn't really matter. All right. What's up, Hexon, bro? I'm good, man. Good, good. Yeah. So we are doing some like machine learning. Yeah. So this PyTorch module, no. So I'm gonna tell you like how big this is. Okay. Let me just show you what is this PyTorch thing. Okay. So this actually came from Facebook, and this guy, Indian guy, who was doing his PhD dissertation on I don't know, it's like in Canada or something. I don't know, but he was doing his PhD under Jeff Hitton. Um, that guy, the guy who actually invented back propagation or something. Um, yeah, yeah. I'm gonna put some music on, but what he did know when he got into Facebook, he actually developed this. So there was like library torch, he implemented in PyTorch. Now PyTorch actually what it did, it actually like accelerated the development or like uh, of machine learning basically. So this is writing deep learning model with the Python in syntax. So whatever you see, so like you see this chat gpt, okay, some some code of chat gpt is using this, okay. You see llama index, the meta ai, they are all running this model pytorch, okay. They are using pytorch to build this uh, they're they're running their whole stack with pytorch, okay. What training model does FreqAI use? Random forest, large gbm, or neural network? You can use anything, you can use any model, so you can basically select it. So I'll tell you what I mean, okay. So um so I'll just go there, Freq trade, help here, and so basically it's like you can select the model with yeah, so Freq trade io, you go there, and then so here Freq trade, so we were in the configuration, right? So you can actually select what model do you want, okay. You see we talked about cat boost, light gbm, this. So you basically have to just pass this FreqAI model. So in the configuration now, this docker compose file, so once you write this, so you have to change this. So instead of this, so if I create new configuration file for torch model that we're going to deploy right now, okay. We're going to deploy it right now, so I'm just going to name it 4. Yeah, hang on, I'm going to put some music, guys. So it's good, must be good now, I think. Yep. So thanks Exxon. He's our DJ. Okay. So actually here, no. So let's actually deploy it, okay. So let's deploy this thing here. Just know that, like, okay, deep learning is the key to solve the FreqAI problem, all right. So there's that. All right, now let's go ahead and do it, okay. So we want to use this, all right. So if I copy it and paste it here, so you see, so let me do it like this, okay. Config strategy FreqAI model, this, okay. So we got that. So what I'm gonna do, I'm just gonna, so we got the config already set there. I'm gonna take this strategy. FreqAI strategy is the same. FreqAI model that I'm gonna use is like this one, okay. And strategy template was is the same. So what it is now is like see guys, this PyTorch ML regression now is like you can find it here. Okay. So check this out. See, PyTorch MLP regressor. So this is the model that we are using. Okay, if we want to create new model that we're gonna use this fit in a different way. Okay, like we have to like follow the coding process, but the thing is like this, it already exists there. Okay, so if I want to deploy it now, I'm just gonna deploy it right now, and then you're gonna see like the training process here is like a bit different. Okay, so let me show you. So I'm gonna go here and create new config file. Okay, I'm gonna name it as 4. All right, and here, yeah, just keep the same. Okay, just everything is same. And yeah, so in order to deploy it, what we do, so this is what we do. Here we come, and then we just deploy it. So let's do that. So BTC, I'm gonna go to FT user data, start.ai model development, and then just like local deployment, put it there, and then like name it as 004. So it's gonna pull it out and then deploy it, deploy it on Docker container. Okay, so guys, please use Docker container for your deployment. Okay, don't deploy it from the terminal. Okay, because you will have breaking point. Okay, it's like when it's like break, then you have to start over again. Okay, we don't have to do that. All right, use Docker container. Okay, so here it says what is saying, cannot be oh shoot, so I actually like didn't change it, this one. So just name it as 4. That's why the problem was happening. And here what you want to do now is like so this is where we use the config file. So this is we're going to be talking about later on, but yeah, hang on. So if you want to use GPU now, you gotta do the model type here, task. So where is it? GPU. Yep, see here, n jobs, thread count, and task have to task type. I'm gonna set it GPU. Okay, so here, so model training parameters, right? So we got then the subdirectory, and here we gotta do task type as GPU. Okay, so now it's gonna use GPU. All right, so let's see and do it for so yep, done. All right, so if I go ahead and look into it, you can see 4 seconds ago we deployed this model. Now I'm gonna look into it. Bond 004. So here you can see that it's gonna start our training procedure now. Yeah. So and hang on. Yeah, we're gonna change the unique ID to later different things. See, this is why it's important. Okay. First PyTorch model. Okay. So this is where this deployment comes handy. Okay, so it's gonna start and then keep start. Just it just takes very small time for your CI/CD pipeline to kick in. Okay, so yep. All right, so we did that PyTorch module. All right, let's talk about like how it's like how it's working. All right, so you should read this one to install in your local machine. Okay, now let's talk about here. So structure model, you can construct your own neural network architecture in PyTorch by simply defining your NN module. class inside your custom FreqAI model. Okay, so and then using that class in your defined train function, here is the example of logistic regression model implementation using PyTorch. Should be used with, you know, binary class loss. So it's like BCE loss, uh, criterion for classification task. Okay, guys, can you let me know if it's the music is loud or not? I mean, I think I should keep it low, I guess. Okay. All right. So logistic regression, if you don't know about logistic regression, it's just like binary classification. That's it. Okay. Yeah. So this is my cool PyTorch binary classifier. So this is, I'm going to teach you guys later on what it means. But the thing is like, we can create this. Okay. All right. So this is where we are using this. We are using around here. Okay. So torch optim, this is Adam optimization, this is logistic regression, input dimension and features. So let's talk about it here, and then what we're gonna do, we're gonna implement this. We create a new model and then we use our custom model, you know, like custom PyTorch model is the best fucking thing, I'm telling you. Okay. uh, all right, so let's do it. Okay. Yeah, so let's read about it a little bit and then we do it. Okay. So the PyTorch model trainer performs the idiomatic PyTorch train loop, define our model, loss function, and optimizer, and then move them to the appropriate device, GPU or CPU. So this is class names. We get the class names. Okay. Class names means the prediction that we are running. Okay, up or down. So this is what a convert label column to int. So we are basically converting, if it's up then it's like 1, if it's down it's -1, something like that. Class, just classification. And features, we get it like this. Model is our logistic regression, then we convert it to device, which is GPU. We're going to use GPU. Optimizer, we're using Adam optimizer. Criterion, we are using, you know, cross entropy loss. Init model, just like initialize with random weight. And then trainer, this is what we are using, PyTorch model trainer. We pass the model, optimizer, criterion, class names, device, init model, data converter, and then like keyword arguments, and then we feed the model. All right, and we return the trained model. Okay, now this is the explanation of that, what we are doing. Let me just like continue. Okay, so inside the loop we iterate through the batches in the data loader. Okay, move the data to the device, compute the prediction and loss, backpropagate it, and update the model parameters using the optimizer. All right. So it's all doing the learning part. Okay, now in addition, the trainer is responsible for the following: saving and loading the model. So this trainer is responsible for saving and loading the model and converting the data from pandas data frame to torch tensor, which is optimized in its own in its own, like, you know, optimization library. All right, so it's basically it's CUDA thing. Okay, I'll tell you guys later how it works, but just know that like once you have GPU, you know, it's just like it becomes accelerate, like, you know, it's just trains like a ninja. You know. Yeah, so integration with FreqAI module is so like all FreqAI models, PyTorch models inherit iFreqAI model. So iFreqAI model declares the three abstract methods, which is train, fit, and predict. So to show you that it's true, so when we go to the base models, we got this base PyTorch classifier, you know, so or just base type PyTorch model. So we got this base type PyTorch model and see iFreqAI model that they are like. So if we go there now, so you can see that like come on man, I want to jump there. Anyway, um oh, I haven't logged in. Okay, so that's why. anyways, like once you go into that depth, it's like you will see that we have to inherit that classes to produce the output that we want. So we implement these methods in 3 levels of hierarchy from top to bottom. So here you see base PyTorch model, which implements the train method. So all base PyTorch, everything inherited. Okay, so base PyTorch responsible for general data preparation, that is data normalization, and calling the fit method, which sets the device attribute used by children classes, sets model type attribute used by the parent class. Okay, so it's just, guys, like go ahead and like look into it, what they are saying here. So if I go there as well, you can see the data drawer FreqAI interface. So if I go there, I can look into it, FreqAI model, right? So you see this in it. Okay, now we have start, so it prepares data and something, then like clean up, shut down, start scanning, back testing module we have live. So you can see all the classes there, okay, which is very important. All right, so this is what they're showing you, freqai.freqai.freqai interface. That's where we went there. So freqai.freqai interface. Okay, so this basically all inherit this class. This is your top class. All right, so this is your top class which everyone's inherited, this one. So if I want to create custom PyTorch MLP classifier, I have to call this base PyTorch classifier. It will call based PyTorch model and it will inherit this one. So it goes on that like top to bottom approach, and this is how it's implemented, which is like really really intelligent and cool too. Okay. So yeah, so we got the base PyTorch model, which is which is inherited by this one. Now we have base PyTorch classifier, all this stuff, which implements the predict method. Here, star represents a group of algorithms such as classifiers or regressors, responsible for data pre-processing, predicting, and post-processing if needed. Okay, now third one is like this one, PyTorch MLP classifier. So we are getting the specific of it. So PyTorch everything classifier is a regressor, implements the fit method responsible for the main train flow where we initialize the trainer and model object. So why they have put is star noise, like MLP is mean like just neural network. You can have convolutional neural network, you can have LSTM, you can have transformer model, you can have all kinds of, like, we're going to work on liquid neural network. So that's the like top of the game. It is like compute optimized, and it's very less model size, and it outperforms every other deep learning model. So we'll see how it goes. Okay, and we're going to implement it live. So yeah. All right, so full example is building a PyTorch regressor using MLP, multi-layer perceptron model with MSE loss criterion and Adam optimizer. So this we can use it, but hang on, we're gonna use this one first. Okay, so but first let's complete this. So here we create a PyTorch MLP regressor class that implements the fit method. Okay, see, implements the fit method. The fit method specifies the training building blocks, which is model, optimizer, criterion, and trainer. So it's like your trainer class. We get output from it. We inherit both base PyTorch regressor and base PyTorch model. So see, base PyTorch regressor, and which actually inherits base PyTorch model. Okay, so where the former implements the predict method, which is suitable for our regression task, and the latter implements the train method. Okay, so this actually implements the train method, but this actually implements your predict method. Okay, so that's why we haven't wrote the code for it. Okay, so here this is setting class names for classifiers. So when using classifiers, the user must declare the class names or targets by overriding the FreqAI model class names attributes. Okay. So this is achieved by setting self.freqai.class names in the FreqAI strategy inside the set FreqAI targets method. So for example, if you are using a binary classifier to predict price movements as up or down, you can set the class names as follows, like this, right? That we already did. So self.freqai.class names down, up, and this is what we do, right? See the full example here. And improving performance with torch.compile. So this is, guys, important. Okay, so torch provides a torch.compile method that can be used to improve performance for a specific GPU hardware. So more details can be found here. In brief, you simply wrap your model in torch.compile. So once we do this PyTorch MLP model, so we see this. Now we got that. Now, so this model, okay, MLP model. So this models or self to 2 device. We did that already, right? Now, instead of that, after that, we have to compile it. Okay, that model we get, then we can, use that model that's optimized, which is gonna save a lot of GPU compute power. Okay, then proceed to use the model as normal. Keep in mind that doing this will remove eager execution, which means errors and tracebacks will not be informative. Okay, anyway, so we got that. Let's see what our PyTorch model is doing. Okay, it's been 11 minutes. So it has actually started training. Okay, so let me show you. So see, we have first PyTorch model training this. We can actually look into it. So I go there, user data, FreqAI model. Here's the models, and this is our train. Okay, so we can see the TensorBoard login too. So okay. So how we can do TensorBoard login now? I actually want to show you guys the training procedure. So let's check it out. Yeah. So see, now I'm gonna search for TensorBoard. All right. So see, once we get to that directory, now models unique ID, we just do this TensorBoard login directory. So what I'm gonna do, I'm gonna go there and just like do the TensorBoard. Let me know if you guys have done this before. Okay. Models. So TensorBoard. Hang on. I think I have TensorBoard there. TensorBoard log directory. First PyTorch model, and then what I'm gonna do is like port, yeah, 8075. I'm gonna do it there. So it's loading. So we got the TensorBoard. Now here you can see the training process, okay, which is really cool, by the way. So see here, if I zoom in, I can see all the different training procedure. Okay, so you see this subtrain 1000 SIP Doge, right? See, we are, so you can see the color. You see the color here, right? So this color is for training of that Doge. SIP is like you have this. SIP. You have training for this. So this one and this one. So you can basically see the training process as well there. Now, so this is your train loss. This is your test loss. Okay. So check this out, the test train loss. Okay. So training is going really well here. All right, we actually want to see when we are training. No, we actually want to see the loss going down. All right. Okay. So it's going good. Um, what were the test loss though? Test loss is like bit, um, it's cool, but yeah. All right. So that's our train loss, and we can actually like see it individually as well. So instead of star, we can see like relative or like wall. We can look into it like this from different perspective, like in each of the how it's doing. So see, training is doing well, but the test is like test loss is increasing, so over time it's gonna get better. Okay, now if I want to only see the for this one, so step, now we can see it, enable range selection now. So you can use all these different point. There's also like a hyperparameter optimization as well for later use. Yeah, we're gonna take a look into later on, but just individual training, how it's going, this is what you want to see. Okay, so this is your TensorBoard. All right, now hope you guys like it, this one though, because it's very very important to do this, um because so see all this, we can what if tool, we have what if tool, we have mesh, we have h parameters, text, histograms, we can look all kind of tools here. Okay, so this is the magic of TensorBoard. All right, now okay, so we got that running. Now training is doing well. Okay, now what we want to do now is like we want our custom model. All right, so this is our custom model that we want to do, the PyTorch one. See this one, so we already deployed one PyTorch model here, right, with the fourth. So hang on, so this one, check this out. So this one here, we are using PyTorch MLP regressor, and we are using the same different strategy. Okay, now what I want to do, I want to do custom strategy. All right, now let me see how far we are in the stream. We are already 1 hour, so I think we should better pick this up in the next stream. Yeah, but yeah, let's do it on the next stream. Okay, what we simply have to do now is just like so we need this strategy. All right, custom strategy here. Instead of regression, now we will have two different target, and model, no model, for model we need different models. So like here we have PyTorch MLP model, here see this model, and this we have PyTorch transformer model. So this is custom model. Okay, so MLP model, we use the MLP model here. See, this is MLP regressor, but you know what I mean. So when we're going to be coding, PyTorch model is going to be here. You see, this is standard like neural networks. Okay, see NN module, we are inheriting the NN module, then we're building the block, feed forwarding. So it's a bit technical, but the code I'm gonna write, I'm gonna share it so that you guys can reproduce as well. So this is transformer architecture for the same. So to show you guys like very quick now, it's like I just copy it, and okay, so here I'm just gonna set it as 5. Okay, and so here what I'm gonna do, instead of that I'm gonna use transformer model. So this one, FreqAI model is transformer model, strategy is same. Okay, and yeah, technically speaking, that's it. We just need this one. So right now let me check if there's like some parameters there. Dropout percentage, yeah, everything is defined there. So yeah, I think we are good to go. So instead of Doge, let's take Bitcoin, or you know what, let's take Uniswap, and we take AVAX. All right. So yep. So here what we're gonna do, we have to send this model as well. Okay. So here, let's see. So we are actually like sending all the models there. So we already got that, these models there. So we have 2024 May week 1. So here, I'm just gonna save this one, 2024. Okay. So that's for your like strategies. FreqAI, FreqAI models. But for FreqAI model, now this one. So we also have like FreqAI model paths. For this one, we get Freq trade, user data, strategies, FreqAI models, 2024 May week 1. Okay. So what you can do here, no, you can find it here actually. So let me zoom it out. So parameter running FreqAI. Okay. So here, I'm just gonna do a FreqAI model. So yep, FreqAI model. Okay. So list FreqAI model. So see FreqAI model path, right? So see, we can send the FreqAI model path there. So it's gonna just look for it on that path. Okay. How I know this? See here, when I sent it on 4th here, strategies, FreqAI model 2024 week 1. See this one. So we got that one. So let's deploy this thing. Yeah. So what I'm gonna do, I'm just gonna like deploy it. Okay. So go back around here, I think. Yep. So local deployment bot 005. Hang on, just change it a bit though. Here name it as 5. Here change it as 5. Okay. Now we got that strategy. This. Now let's check it out. Yeah. Okay. So it's running. It's this one question, I think. What is the question? Aditya Gatti. Yeah, bro, I'm from India. I know. I think you're asking like, where are you from India? Yeah. So yeah, I've been traveling in India for like long time. So yeah, technically not talking about it where I'm from, but yeah, just traveling and exploring India, man. So see, this impossible to load FreqAI model. This class does not exist or contains Python error. So there's some sort of error there. Okay. Yeah, some sort of error there that's happening. So we're gonna fix it in the. Hang on. Let's use this one. Okay, to show you that like this shit works. Okay, so instead of that, I'm gonna use this model. Okay. So I'm gonna deploy it again. Yeah, trading and traveling, man. That's the best thing that yeah. It's like that's why I started this channel. Actually, my life purpose is to like, one of my life purpose on top of the list is to like teach you the guys who are traveling and like make money while traveling. So it's just like you learn to farm money so that you can travel. And like trading is like the system I built, man, is like I'm telling you guys, like you can get notification on your Telegram, you can get notification on your Discord, and the technical analysis we do on our channel is like the top class technical analysis. All right, so yeah, you guys gonna be seeing it later on. It's like that's why, like the first thing that I'm gonna do is like it's gonna be free. You guys can sign up, you guys gonna get the notification on your Telegram as well. So yeah, so because coming up I'm gonna run this YouTube video series called Breaking Good, where I'll get like 3 or 4 students, and like I'm gonna teach them live how to make money, so that you guys can see it like in live evidence that like, okay, this shit is real. Yeah. And the best part is like these are the guys who like traveling. They're like literally traveling right now. So yeah, this is gonna be interesting. Okay. And they're also from like different countries around the world. So from UK, Belgium, Netherlands, like yeah, it's gonna be interesting. Yeah. So I think it's throwing the same error. I don't know what the problem is, but I think we have to fix it later on. So user data strategies FreqAI models 2024 May week 1. I don't know. I think I got it right? So what the heck is the problem here? So bot 5 user data strategies FreqAI models 2024 and this, right? There must be some like Python error or something. Okay, yeah guys, so we're gonna fix it later on tomorrow with the custom feature. Okay, so custom feature is a custom model. We're gonna build this one. Okay, binary classification, and then PyTorch classifier as well, this one. Okay, so yeah, all right guys, thank you for watching the video. I hope to see you guys in the next video as well. If you haven't liked the video, please so this guy is saying I'm tired of my job, I'd like to trading for better life. Yeah man, it's like if you guys don't know, it's like I got this tattoo. Okay, I'm gonna show it to you. Check this out. Bitcoin, live free or die. Is it visible? I don't know. So yeah man, I see this is very personal to me. It's like we do have our freedom, but like this job thing is like created this wall of 9 to 5, where like you have to stay on that fucking like 4 wall and just live there. Yeah, Bitcoin stands for freedom, and the little things like you guys might know about it is live free or die. It actually comes from American Revolution, okay, in 1776. That's the main reason each one of us got our freedom. Okay, what they did is like British Empire was the biggest fucking empire in the world at that time. Okay, what they were actually like the part of British colony. Okay, now what they said is like, we are colonists, we bought this motherfucking land. Okay, we're not gonna let you take our freedom. So they just like fought each and every one of them, man. It's like and actually Bitcoin was invented during 2008 financial crisis. If you guys don't know about it, there's like lot history about it. So that's why I'm gonna start this podcast, where I'll talk about this because like most of you guys are like, I can tell you guys are very involved into it, are dedicated into it, but like not a lot of people know about the history and why Bitcoin is very important. Because this is literally a digital gold, guys. If we have digital gold, we have like lost use for real gold basically, until and unless there's like World War III, where it's like Bitcoin actually runs with on computer. Okay, so if you destroy all the computer, it's like you have problem with it. But the thing is like the code is still running there. Okay, it's like you can still mine it. So no matter what happens, guys, Bitcoin is gonna live. Okay, and people, all of the big investors firms are like putting the money in Bitcoin. That's why you saw that, like, Bitcoin ETF, like 8 different Bitcoin ETF was passed from SEC. Just imagine, from SEC, the same entity or same department in US, federal government. It's like they were basically creating the barrier to stop Bitcoin and all this digital currency, but it's so fucking strong that they can't even stand a chance. Okay, so yeah, guys, like Bitcoin, live free or die. That must be our logo. Okay. Anyway, guys, Telegram link will be coming up. Probably next week. You know what? I'm gonna put it right now. It's just that like I started it. So hang on. Just to show you guys that this shit works. Like, this is just in the testing phase though. Okay. Don't. Uh, um, Hang on. So you can use it, the trade setup, but it's in like 15 minutes time frame. So basically, right now you can see here. So you see this is what I call 80-20 business. Okay, so you see it's like the trade is going on and it's like $555 in profit. So here you can see daily profit, balance, performance, like status, everything. And like in order to add you guys, just like I'm gonna copy the link. I added couple of people there. So there's like trade actually executing right now. Okay, so I'm gonna copy the link and just gonna put it there. Okay, so let me show you. There's like different trade was executed there. So see here, short, direction short, this amount, this total invested, this. So yep, so we have 8 trades running on there. Okay, so all right, guys, here's your reward. Okay, so here's the Telegram link, and you guys should join it. Okay, so I'm just gonna copy the link and just gonna paste it there. Okay, so guys, keep in mind though that like this is actually, so this system, no, so I'll tell you. Okay, hang on one moment. So this system is actually running live. So I'm gonna fetch the data. So this is the system. Okay, this is running on 15 minutes time frame. So we're getting the data. Okay, so someone joined the group, right? So see this one, we got this data. So this is the prediction you're gonna be getting it. Okay, on 15 minutes. So if I get the BTC, see, check this out, this one. So this is the prediction you're getting there. Okay, so if it's gonna enter short here, you're gonna get short trade notification or Telegram. See, so you can see, okay, it's like the prediction is quite good. All right, so that's what. So this all you see, we are getting, I'm sending the notification on Telegram on that channel. All right, so this guy is added currently. Okay, so I'll see you guys in the next video as well. And from the prediction point of view, I think we got it sorted out, right? So yeah, guys, it was really nice seeing you guys again, and hope to see you guys in the next video too. If you haven't subscribed yet, please subscribe, like the video, so that it helps YouTube algorithm to get it in the top list when some people searches are all. And also hit that notification bell so that like you get notification as soon as I start the live stream. Okay, so thank you so much, guys, and I'll see you guys in the next video. Happy trading.